Hello class, welcome to another lesson. Today's learning goals are I can determine the difference between and identify similar and congruent images. We've been doing this the last couple lessons actually. I know the last lesson didn't have this as a learning goal, but that would have been 4 learning goals and that's quite a lot. So I just kind of left it out, but we are still continuing working on similar and congruent images. And then the last one is I can rotate an image 90 and 80 degrees. Okay, so let's go ahead and get started. Today's transformation that we're going to talk about is rotations. Specifically, we're going to start with rotations of 90 degrees, and we'll touch on 180 degrees because it's something that we actually already know how to do. Okay. So to rotate something 90 degrees, you have to switch the original x and y values. Okay, you just flip them around. Okay, and then determine which x and y value is negative or positive, and this depends on which quadrant you rotate your point to. Okay, so let's say we start off in quadrant 1 and we want to rotate our image 90 degrees clockwise. Okay, that would end up in quadrant 4, and everything in quadrant 4 has a positive x coordinate and a negative y coordinate. As you guys can see, it goes to the right of the origin and downwards. Okay, so if we had something over here like 3, 4, okay, to rotate 90 degrees to the quadrant number 4, okay, what we do is switch the 3 and the 4, okay, and then make the 3 a negative number because the y coordinate has to be negative since it's inside quadrant 4. So therefore it would be 4, negative 3, as right here, 4, negative 3. Okay. Then let's say we wanted to rotate 90 degrees counterclockwise, and that would take us into quadrant 2. Anything in quadrant 2 is going to have a negative x coordinate and a positive y because we go to the left of the origin and up. So what we would do is, again, we'd switch the x and y, so it would become, we switch the 4 and the 3, so it would be 4, 3, except that the 4 now is the negative number, so it would be negative 4, 3, so it would be negative 4, up 3, approximately right here. Okay. Finally, let's say we wanted to go another 90 degrees counterclockwise. Okay, so we go from here down to here into quadrant 3. Okay, again we would switch the x coordinate and the y coordinate. Okay, so we go back to 3, 4. You can set both coordinates are going to be negative, so we'd have to be negative 3, negative 4 right here. Oops, that's not right. Let's fix that and do 3, negative 4. Okay, and group that together again. But and so we have that. Okay. Again, every rotation of 90 degrees requires you to switch the x and the y coordinates. Okay. And then figure out which ones are supposed to be negative and which ones are supposed to be positive. So let's try this one out. This one says rotating 90 degrees counterclockwise about the origin. So we're going to, what it means by about the origin is that this is kind of the anchor point, okay? And so we're rotating around that anchor point. And when we do that, we're going to have this E go into quadrant 1, C is going to go to quadrant 1, D is going to go to quadrant 2, okay? And so we also said that every time we do that, we have to switch the x and the y. So this becomes E goes right here, okay? So this 2 negative 1 becomes 1, 2. C, which is 3, negative 3, becomes 3, 3, okay? Because when we flip it, we have to also make them positive because it's going to quadrant 1. D, which is going to go to quadrant 2, is currently 5, 2. It's going to become negative 2, 5. And it should look something like this, okay? It also says, are the two figures congruent or similar, and why? You can see that if I were to cut this image out and I could put it directly on this image, and so therefore this is going to be congruent because the angles and the side lengths don't change. The vertex of image of E is 1, 2. And then we are to rotate this again, okay? And so, oops, this kind of goes into there. Let's see if we can do something about that. Well, you can see that 1, 2 becomes negative 2, 1, okay? Because we're going to rotate this again over here to the new quadrant 3 over here. D goes to quadrant 3. This E becomes into quadrant 2. This C goes into quadrant 2 as well. So we're going to again flip it and then see which ones need to be positive, negative. D is going to be double negative. E is going to have a negative x, and C is going to have a negative x as well, as we can see right here. Okay, and that image should look something like this right here. Okay, notice how this is can be obtained by reflecting the original image across the x and the y, because this E would across the x would go right here, and across the y would go right here. Same thing with the C, reflected across the x, go right here, then across the y, go right here. D, same thing, across the x would go down here, and across the y, down here as well. So therefore, a rotation of 180 degrees is the same thing as the combination of reflecting over the x and reflecting over the y. So in this one, we're going to rotate it 90 degrees counterclockwise across the origin. Okay, so that means that these 3 points are going to go into quadrant 3, and this one that's already in quadrant 3 is going to be in quadrant 4. Okay. Again, we have to flip the x and the y and determine which coordinates are going to be positive or negative. So go ahead and try this out on your own. This W right now is negative 4, 3. Okay, so it's going to become negative 3, negative 4 down here. This x, which is negative 3, 3, is going to be negative 3, negative 3 right there. This y, which is negative 3, 1, is going to become negative 1, negative 3. And this one right here, which is negative 5, negative 1, is going to become 1, negative 5. And that means that it should look something like that right here. Okay, rotating at 90 degrees. Are the two coordinates similar or congruent? They are congruent because, again, same side lengths and same angles. And was the x-coordinate of the image of V? That is going to be 1 over here. Okay. So here we have to find out what the rule is. Okay, this is clearly a rotation. Okay, because this is 1 or negative 1, 5, and this becomes negative 5, negative 1. Okay, it's very important to identify which one's the pre-image, which is this black one, and then which one is the image. This is the image right here. So we're going counterclockwise by 90 degrees. This is the pre-image, this is the post-image or image, and here we can see that this negative 1, 3 becomes negative 3, 1. Okay, so we can see that this is a rotation as well, and this time it's going clockwise. Okay, clockwise. So it's a rotation of 90 degrees clockwise. We're dealing with multiple transformations. So we're going to take this one and do a slide to the right 1. Okay, and then rotate it 90 degrees counterclockwise. So it's going to go slide 1. And then counterclockwise. Go ahead and try this out on your own. If we were to rotate, or slide this one to the right, the image would look something like this. Okay. Then a rotation of 90 degrees. Okay, so this is negative 1, 4. It should become going into the quadrant 4. It should become negative 1, 4 becomes negative 4, negative 1. Okay, so negative 4, negative 1 should be right here. And conversely, this point is going to be on the edge as well over here, giving us something that looks like this right here. Okay. And the resulting figure, is it congruent or similar? Congruent, okay, was the location of the vertex M. You can see that is negative 5, negative 1. Okay. Now, just a quick note. Obviously, these are a lot of steps. Okay. Rotating it around, things like that. What I like to do is do what we did back up here with each vertex. Okay, when I'm rotating it around, I like to write it out first before plotting it on the graph. Okay, it makes a lot of things easier. And the hardest thing about this one, and this is probably the hardest transformation, is not the concepts behind it, but just making sure you're keeping track of all your points. And it's easier to do that if you just keep writing them down as you go. Okay. And obviously you can tell pretty easily if your image is properly rotated or not. It should look exactly the same, and you should be able to tell the rotation as well. Over here, we're going to do multiple transformations. Okay, this time we're going to reflect it across the y equals 1. Okay, that is a line. Okay, and then we're going to rotate it 180 degrees. Go ahead and try this one out on your own. Y equals 1, that is a horizontal line like this. Okay, so when we reflect it off that line, each point must be equidistant from it originally. So this is 1 point down from that line. So when we reflect it, it's going to be 1 point up. This is 2 points up, so it's going to be 2 points down, etc. So when we rotate it, we should get an image like this. Then rotating it at 180 degrees. Okay. Notice how this doesn't say counterclockwise or clockwise, because it doesn't really matter, because 180 degrees will get you the same image both clockwise and counterclockwise. Okay. And so what we have to do is just multiply each one of these points' coordinates by -1, both the x and the y. So this is going to become negative 4, 0. This is going to become, this is 1, 2, so it's going to become -1, -2. Okay. -1, -2, and so forth and so on, getting you an image like this. The resulting figure is congruent or similar. Again, you can't change the lengths with a rotation or a transformation or a reflection, so therefore it is congruent. It was the location of C image of C, that is -4, 0. I also want to point out that if you look at this rotation right here, this A point right here, okay, before we rotated it, is 1 box down and 1 box over from the origin. And conversely, the same distance applies to the image of A, which is 1 box up, 1 box over. Okay, same thing with this point right here. This is 4 spots away from the origin. This is 4 spots away from the origin. This is 1 over 2 down. This is 1 over 2 up. Okay, and the same thing applies for all of these points. Okay, so back here we had a point, we had this rotation right here. This y is 3 over 1 down. This one's 1 over 3 down. Okay, so all that distance is maintained from that origin. That's what it means to rotate around that origin. The distance of each one of these points, okay, when it is transformed, still maintains the same distance. Okay, 3 up, 3 over. 3 down, 3 over, okay, maintaining that same distance. Going back to our learning goals, you should be able to determine the difference between and identify similar and congruent images, and know how to rotate an image 90 and 80 degrees. If you feel confident with those two things, go ahead and try the practice.